have been learning a lot about insects over the past few weeks. We've learned some of the characteristics of insects, that each of them has three main body parts: a head, a thorax, and an abdomen. Insects also have exoskeletons, some have two antennae, and sometimes they have wings. We've also been talking about how insects communicate with each other. Look just below the knee on the front leg of this cricket. Do you see that smooth patch of skin? That is where the cricket's eardrum is. And that is how the cricket communicates with other crickets. The eardrum bends in and out to catch the sound waves of other crickets so that it can communicate. When a honeybee discovers a particularly good source of nectar, it returns to the hive to communicate that information to other foragers. First, it lets the other foragers smell the pollen so that they can identify the type of flower. Then it communicates by performing a complicated and special waggle dance. It will circle about in a pattern like a figure 8. It wags its abdomen as it moves through the middle of the dance. The bee's repeated movements, circling and waggling its abdomen, tell the other bees exactly how far away and in which direction from the sun the flowers are located. A bee that thinks she has found a really good flower patch does the waggle dance with lots of energy. Ants communicate by emitting chemical signals that other ants can smell with their antennae. Soldier ants, like the one in this picture, will use these signals to warn the colony of danger. Ants also communicate through touch. If an ant is hungry, it taps a food gatherer lightly with its antennae to let it know that it would like to eat. Ants will then exchange the food mouth to mouth. When food is shared, the ants also share and pass along some chemical information that is important for the entire colony. If an ant gets trapped in the soil, they can produce a squeaky sound by rubbing their joints together, and other ants will be able to hear their cry for help through their own legs. Today, we are going to learn about how some other types of insects are able to communicate with each other. Before we start our story, let's talk about what the word communicate actually means, and a couple other words that we'll see too. The word communicate means to share or exchange information. In our regular classrooms, you usually have to communicate with your teachers in order to understand assignments. Right now, because we can't be in our regular classrooms, we are communicating with our Google Classrooms. There are lots of different ways that we are able to communicate on Google Classroom. We can do videos, or we can do emails or chats. See if you can think of another way that humans often communicate with each other. Bioluminescence. That is a really big word, boys and girls. I want you to say that one with me. Ready? Bioluminescence. Bioluminescence is light that is given off or emitted by some plants and animals, like fireflies, that is caused by a biochemical reaction. Lanterns. Lanterns are lights that have some kind of covering. Often it's glass or really hard plastic. Humans use lanterns to find their way in dark places. We're going to learn another definition for lanterns in our read aloud today. Can you blink, boys and girls? So can I. But does your abdomen light up when you blink? How could you tell? If you're blinking, you can't really see your abdomen. See if you can find a sibling or a parent nearby and ask them to watch your abdomen while you blink. Did it glow? Did they say it did? Probably not. If humans were able to produce their own light, they might never have invented the electric light bulb. We fireflies have been around long before electricity, or even candles. Our light organs, called lanterns, are located in our transparent or see-through abdomens. On fireflies, lanterns are the part of the body that produces light. So we talked already about how lanterns are kind of like large flashlights that humans use to see in the dark. But when we talk about lanterns on fireflies, we're talking about the part of them that lights up. When humans first discovered us lighting up the forests, they were amazed by how much light we produced. In ancient China and Japan, people collected us in transparent jars and used us as lanterns to find their way in the dark. Remember, transparent means that it's see-through. They named us fireflies. But we are not flies at all, and our light, unlike that of a fire, is cold. Cold light is the way your ancestors explained our beautiful magical light. Scientists now know that chemical reactions create the light, and they describe this process with a much bigger word. They call it bioluminescence. There's our big word again, boys and girls. Say that one with me again. Ready? Bioluminescence. Let's break that into sections. Bio means living, and lumen means light. I think that's a pretty good name for it, don't you? Fireflies are living lights. Other plants and animals glow or light up like tiny electric bulbs, but most of them live in the ocean. Certain types of squid, jellyfish, corals, and even sharks glow beneath the water. Plants such as algae in the ocean can also glow on the surface of the water. At times, this bioluminescence is so bright that it looks as if someone flipped a light switch beneath the water. It is less common to find any land animals that glow or give off light. I've told you that we are called fireflies, but do any of you call us by another name? Some people also call us lightning bugs. But we are not flies nor bugs. We are actually beetles, another group of insects. Take a close look and see. Like all insects, we have 3 body parts: a head, a thorax, and an abdomen. We have 6 legs, 2 antennae, an exoskeleton, and like most insects, 2 pairs of wings. We undergo a complete metamorphosis, changing from egg to larva to pupa to adult. Remember, a complete metamorphosis is a change that is so big that the insect looks completely different after it happens. Some of our eggs and larvae even glow. Have you ever heard of a glowworm? Glowworms are also misnamed. They are not worms at all. At the larvae stage, a lot of insects look like worms, even though they're not worms. The larvae of fireflies and other insects are often called glowworms because they live on the ground like worms, and they glow in the dark. In order for any animals to survive, they must reproduce or have babies. That means that we must all work hard to attract mates. Fireflies glow when they are seeking mates. The males fly through the dark, flashing very specific signals to females who sit patiently and wait for them. Our yellowish-green lights stand out against the night sky as we signal one another with special codes. When a female recognizes a male code as being from the same species or type, she flashes the same code back to him, and the male lands beside her. Have you ever noticed how some fireflies flash close to the ground with one pattern, but others seem to be higher in the air with a different flash pattern at a slightly later time of the night? These are males of different species attracting their own females. Watch us next summer and you will be able to see what I'm talking about. Alright, boys and girls, our story has been narrated by our firefly friend so far, but we are going to switch narrators now. Look at the picture. Who do you think is going to start narrating now? Hi there. I bet you're surprised to see me today. I am not bioluminescent. I don't glow, but I do sing. That's what I want to talk to you about today. Other ways that insects communicate or share information. Fireflies are silent communicators, flashing their glowing lights back and forth. Remember, the part of a firefly that lights up is called the lantern. How do you communicate with one another? You talk, don't you? And what do you use to talk? Your mouths, of course. Although we insects use mouths for eating, just like you, we have no vocal cords or voice boxes, so we don't use them for talking and singing. Even so, us grasshoppers can be a noisy bunch. Have you ever heard grasshoppers sing on a summer day? You won't hear any words, but you will definitely hear a chorus of sounds. Just like birds, each type of grasshopper produces a different song. If you listen closely, you can tell what type of grasshopper is singing by its song. Nearly all grasshoppers have two pairs of wings, but we seldom use them for flying because we spend so much of our lives low to the ground. Male grasshoppers use their wings for communicating with one another. Female grasshoppers do not sing, but they listen very carefully. They hear our sounds with tympanum, eardrums located on the sides of their abdomens. If you look at this picture of a grasshopper, the tympanum is located where the thorax meets the abdomen. It's close to where his strong muscular hind legs attach to the thorax. Grasshoppers, locusts, and crickets all make sounds by rubbing body parts together. Sometimes two wings, and sometimes a leg and a wing. To make sounds, I lift my wings and rub the front wings together. The vein, composed of many tiny teeth on the bottom of one wing, rubs against the sharp edge or scraper on the top of the other wing. It is a little like rubbing your fingers along the teeth of a comb. As the two parts rub together, the wings vibrate, moving back and forth rapidly to produce the sounds that you hear. You may be familiar with my cousin, the katydid. Katydids have long antennae, just like me. As they rub their front wings together, it sounds like they are calling out, "Katydid, katydid." Their high-pitched calls become faster and faster as the outside temperature rises. Some people even say that you can tell how hot it is by the number of times per second a katydid chirps. If katydids live in your part of the world and you are patient enough, you may want to try counting the number of chirps you hear every 5 seconds. Add 39 to that number and you may have an accurate reading of the temperature, depending on the species of katydid you are hearing. Here in Utah, we do have some katydids, but not a lot. We mostly have crickets. But listen carefully and you can hear what katydids sound like. In some Asian countries, in a tradition that has been practiced for thousands of years, male crickets have been kept in cages as singing pets. Do you know where the ears of a cricket are located? You may remember that female grasshoppers hear with special parts on their abdomens, but crickets have ears on their forelegs. The forelegs are the front legs of an animal. Both places must seem a little strange to you, since your ears are on the side of your head. Before I leave today, I want to introduce you to one more singing insect. These insects are often mistaken for grasshoppers and crickets because they look a lot like us. Do you remember what this insect is called? This is a cicada. Cicadas are related to aphids, leafhoppers, and spittlebugs. Unlike grasshoppers and crickets, many cicadas have strong wings and are fast flyers. Male cicadas produce incredibly loud songs, but they do not use their legs and wings to make those sounds. Look closely at the abdomen of a cicada. On its underside, close to the thorax, a cicada has a pair of sound-producing organs called tymbals. These ribbed membranes are a little like the skin of a drum. The cicada uses its muscles to vibrate these drum-like organs. If they're vibrating, that means that they're moving back and forth really, really fast. The tymbals pop and click as they move in and out. Their sound is amplified, or made louder, inside the mostly hollow abdomen, acting like a drum and creating a loud buzzing song. The shrill sound of hundreds or thousands of cicadas singing together on a warm summer evening may be very, very loud. Grasshoppers, crickets, and cicadas all use sound to communicate in much the same way that fireflies use their lights. Males attract females for the purpose of mating, making sure that these winged insects will continue to survive. Next time, we will learn about the largest group of insects on Earth. Take a minute to guess what you think that might be. Okay, boys and girls, I know that in our classes, we've been learning about what verbs are. Remember, verbs are action words. Today, I want to talk about adverbs. Adverbs are words that describe verbs, so they explain how the action word was being done. In our story, we learned that grasshoppers sing. Sing is our verb or action word. If we want to describe how the grasshoppers sing, we would add an adverb to our sentence. We could say that the grasshoppers sing loudly, or that grasshoppers sing softly, or even that grasshoppers sing beautifully. We also learned that grasshoppers' wings move rapidly. Take a minute, what's the verb in that sentence? Grasshoppers move rapidly. Our verb is move. Now see if you can think of what the adverb is. The grasshopper's wings move rapidly. Our adverb is rapidly. Rapidly describes how the grasshopper's wings move. Listen carefully. I'm going to clap, and I want you to clap along with me. As I'm clapping, I want you to think of adverbs that could describe how I'm clapping. Ready? Let's begin. Was I clapping slowly or quickly? Let's try again with a different clapping pattern. Ready? Listen very carefully for this next one. See if you can find an adverb. Am I clapping loudly, or am I clapping softly or quietly? And how about now? Am I still clapping softly, or am I clapping loudly? This week, I want you to pay attention to things people are doing and see if you can think of some adverbs to describe how they're doing it.
All right, my friends, on the board, I have a list of insects that communicate in very particular or special ways. Remember, insects can't talk like humans can, so they can't talk to each other the way we do. They have to communicate in other ways, and each of these insects has a different method of communication. So our insects on our list are the firefly, the grasshopper, katydid, cricket, and cicada. I want you to pick one of those things and tell whoever is helping you today, explain to them how that insect communicates. Go. Alright, my friends, wrap up that explanation in 3, in 2, and in 1. Let's see how we did. If you picked a firefly, remember fireflies communicate by using their lanterns. They use their lanterns to communicate. They flash them. How do grasshoppers communicate? They rub their wings, and sometimes their wings and their legs together. How do they listen? So this is how they talk, but how do they listen? What's that special body part they use to listen called? They listen with their tympanum. What about the katydid? How do katydids talk to each other? They are similar to our grasshopper. They rub just their front legs together. What about crickets? Crickets sing. They sing to each other. Have you ever heard a cricket sing? We have a lot of crickets here in Utah, so I'm sure on some warm summer nights, you've heard a cricket sing. And they listen using their legs. Remember, their ears are on their legs. And our cicada, our last insect, if you chose that one, you know that a cicada communicates by vibrating the tympans that create that loud noise. Vibrating is kind of like rubbing really, really quickly. It rubs its tympans together to make that loud, loud noise. Alright friends, I've got a couple other questions for you about some of the insects that we talked about today. My first question is about grasshoppers. Female grasshoppers use their tympanum, or the eardrums on the sides of their abdomens, to listen to the male grasshoppers. Why do male grasshoppers sing to the females? We know how they sing, but why do they sing? Male grasshoppers sing to the females to tell them that they want to mate with them. That's how they find a mate. I'm going to grab my map for our next question. We learned in today's read aloud that in some Asian countries, so if we look at our map, remember Asia is this continent over here. There are a lot of different countries in Asia. We've talked about a couple this year. We talked about the Asian country India in yellow. And we talked about the Asian country China, which is shown here in pink. In some other Asian countries, it is considered good luck to keep grasshoppers in cages. They keep grasshoppers in cages. Is it male or female grasshoppers that they put in those cages? And why? If you said male, you are correct. They keep male crickets in cages, and they choose the male crickets so they can listen to them sing. They want to hear their song. All right, my friends, do grasshoppers, crickets, and fireflies have exoskeletons? If you said yes, you are absolutely correct. How do we know? We know that grasshoppers, crickets, and fireflies are all insects. And all insects have exoskeletons, or hard coverings, on the outsides of their bodies that help keep them safe and protected. All right, my friends, let's jump right over to our assignment for today. Go ahead and open up the PDF that is attached to your assignment, and I'm going to jump over onto my computer and I'll show you what to do.
All right, my friends, in our last lesson before we did our little break, we made a plan for a narrative told from the perspective of an insect. You should have your plan, whether you printed it or saved it as a digital file like I did. We're going to use that plan today, and we're going to start the second step in the writing process, drafting. Remember, when we draft, it doesn't have to be perfect. Our first draft should be a little rough, and that's okay because we will go back and we will make our writing stronger and fix any spelling errors in our editing process. We are going to use the ideas we had in our plan to create our draft. The PDF for today's assignment includes this page. There are 5 different rectangles on this page. Your story is going to be at least 5 sentences. You can write more sentences if you need to. Our first sentence, the beginning of our story, is called our introductory sentence. Our introductory sentence introduces our characters and setting. I'm going to look at my plan. My character is Beatrice the bee, my main character, who is a forager bee. And she is at a park in the summer. I'm going to write, remember, I'm pretending to be Beatrice because I'm writing this from Beatrice's point of view. That means as the author, when I'm writing, I'm going to pretend to be Beatrice. So I'm going to start, we'll introduce her by saying, my name is Beatrice the bee. I am a forager bee, and today I am at a beautiful park searching for sweet nectar to bring back to my hive. As you're writing, try to use some of the vocabulary words that we've talked about. All right, I have introduced my character, and I've introduced my setting at the park. I did 2 sentences. That's okay if you have to break it up into more than one sentence, but you can just do one too if you can fit all that information in just the one sentence. Our next square is going to be about the middle. Not the middle, the beginning. What happened at the beginning of the sentence? Beginning of the story, not the sentence. Sorry, friends. Let's look back at my plan. What did I say happened at the beginning of my story? So I said she visited 6 different flowers, trying to find the best nectar, and then she finally found one to bring back to the hive. Let's see. I'm going to say I already searched 6. I'm going to put an emphasis on that to show that she is stressed out or excited about how many flowers she searched. 6 different flowers. But none of them had the best nectar. I can see a big, beautiful yellow lily now, and it looks like it has excellent nectar. I will go over and gather it for my colony. We'll call it the colony. That's what I said happened at the beginning. Again, it's okay if it's more than one sentence. If you have to break it up into a couple, that's okay. But you don't have to do more than one sentence. All right, we have got our introductory sentence, our sentences that explain what happened at the beginning. Now we need to explain what happened at the middle. Remember, in the middle in my plan, she runs into her friend Barry, and she does the wiggle dance to tell him where to find the nectar. But she drops the nectar that she had when she does the dance, so she has to go all the way back and get more. On my way back home, I run into my friend Barry. I explained to Barry how to find the nectar by doing the wiggle dance. But while I am dancing, the nectar slips out of my grip. Well, I guess bees don't really hold their nectar, huh? It sticks to their legs. So I'm going to say, instead of slips out, I'm going to say falls off of my legs. Now, I'll have to go back with Barry and gather the nectar all over again. In the 4th box, the 4th rectangle, we're going to write what happened at the end. At the end of my story, Beatrice made it back, and she was able to store the honey in the honeycombs. So I'm going to say, after a long flight back to the hive, I store the honey in a honeycomb. And take a much needed rest. The very last paragraph or sorry, box, not paragraph. The very last box or sentence is going to be your concluding sentence. A concluding sentence wraps up the story and summarizes it, kind of gives it a nice summary, a nice ending. I'm going to say, I'm going to give my audience some more information about bees. Bees are social insects, and each job, such as foragers like me, are important to keep the colony running smoothly. All right, my friends. Your story is obviously going to be very different from mine. When you are finished with your story, your draft, remember this is not your final story, we'll still have time to work on it, so it's okay if it's not perfect right now. When you are finished with your draft, go ahead and turn this one in. You do not need to turn in your planning guide again, just your draft. And when that is turned in, you are all finished with knowledge to date.